Give you a little bit about me. I have been a CS teacher for about 6 years. Prior to that, I taught Latin for 25 years. Let me just see. I am messing this up here. Got it. Let me just get this right here. And I have been a certified teacher here with, oh, I messed this up. Sorry about this. What's the magic thing I type in there where it says edit to make it so I can change it over to presentation mode?
If you're in the edit part and you click the drop down next to slideshow and pick presenter view, it'll put it in your window.
Yeah,
I think embed should also do it.
Embed, that's where I was over here, but this will go. Okay, so and in my time of teaching, I teach at Villa. It's an all-girls academy, and I teach from intro computing and really super basic stuff all the way through the AP classes. And what I've discovered is I teach in the block schedule, and I need my students to be able to kind of break up their time and their rhythm in the class. We're not just sitting in front of the computer the entire time, just coding away. And so I really like to lean on unplugged activities. And there's some I do, especially for my intro to computer programming class. And I'll show you those in a moment. And then, but this past fall, I got inspired by this idea of the robot mazes that are part of the APCSP class. And I just started thinking about it. And when I was thinking about it, I just make games. And so I just took pieces of paper and wrote little ideas on them and created a deck of cards where we could code using a deck of cards. And I've been playing that. I've been playing this game for most of the year with my AP students, just to train them a little bit of how things are going. And then I kept going with this, and I made it a little bit better. I made it so instead of handwritten, I kind of printed out here, but we will get to that game in a moment, and I'll show you. But that's what the beginning of this whole thing was. So I just want to talk about what Unplugged and why Unplugged, and I'll give you some examples that I do in my classroom. I'd love to hear the ideas that you guys have, so I can steal your ideas just so I can share. And then I'm going to go into MazeBot and try to explain that, how it works. And at the end, I've got files for you, PDFs. So if you want to try it yourself, you can print out these PDFs, get a cheap deck of cards from the dollar store, and tape them on and have your own deck of cards by the end of the weekends for you. So that's what we're going through today. So unplugged activities. There are lots of reasons why to do unplugged activities. One is there are times where I get into my school year, it seems to happen at the beginning of each semester, where sometimes my computers just aren't functioning. The tech team has updated something, they've changed something, and my students just can't log in that day. And having an unplugged activity in my back pocket to fall back on and not lose a day of education is really helpful. I know the next one seems crazy, but sometimes you just lose electricity, and we'll lose it for a little bit. And again, instead of just sitting there doing nothing, staring at the ceiling, we can pull this off. Internet, because of the Wi-Fi we have at our school, sometimes when it rains, we lose internet. So these are all just kind of backup systems. But in addition to the backup, probably the main reason I want it is because of just all the multiple intelligences, because of this idea of kinesthetic learning, letting students learn by physically touching and feeling things and logically going things out with their hands and not just sitting in front of a computer the entire time. It also helps just for a change of pace. So sitting at computers, being serious, we can get down on the floor, we can be interpersonal with this activity, we can have a group of, I try to get groups together of 3, 4, or 6, and just so they can be social with each other. So I find unplugged activities really valuable. It also keeps the energy level up in my classroom. In my introduction to coding class, we will do we'll start the class and do 40 to 50 minutes of coding. Then we take a little bit of a break, and then we'll do an unplugged activity. Not every day, but periodically, maybe a couple times a week. We will do that just to keep things going. So that's why I do it. The two main unplugged activities I do are origami and with Legos. For origami, I have 3 unplugged lessons I do. They each take about 30 minutes. If a class is super enthusiastic, we may do it for a few more days, and we do 30-minute sessions over the course of 5 different days. And the way I use origami is I talk about paired programming. I also talk about how a computer can only do what we tell it to do. And so when I do that, I will give them the document, and they will have, one student will have to explain to another student how to do the origami. And it normally is a disaster, just because they are explaining it wrong. It's kind of like the peanut butter and jelly instruction thing we might have done many years ago. But this with origami, I get decorations all over my room when I do it that way. 1 second. Also, just the idea of making rules for language, having there be the syntax of it, that there might be terms we use about folding up or down, or hot dog folds versus hamburger folds. And that's that kind of, there's going to be certain rules of grammar, like coding has syntax. We all have syntax for this as well. This also goes into my paired programming I do a lot of, where I've got to stick them with a partner. They really have to depend upon each other for the navigator and the pilot and things like that. So I will pair them. One has the instructions, one can't see them, and then they will have to create the origami. Another is they just have to see the instructions and follow the instructions correctly and fold it. And I tell them, look, the instructions are the code and you are the computer. And if you've got to follow these instructions. And then we also do decomposition. I do on the last day, we got a little bit more complicated, where they will take an object that's already in origami form, and they will slowly unfold it and reverse engineer to figure out how they can go from the end back to the beginning, and then take their paper and go from the beginning to the end. And so this is how can we take a problem and break it down into its pieces. Another one I love doing, because I'm really into Legos, is I get these 3-in-1 creator sets. They can get any kind. They can be the smallest ones of all. And we just talk about, let's look at the instructions in here. Look how they repeat. Look how it's one little piece at a time, how this little function is running just to say, just do this. And I really try to tell them, when they're writing their code, write it just as simply. It's not these long strings of just linear code going forever and ever and ever. We talk about abstraction, how things get repeated over and over and over again. And that's a really fun one. As I said, I teach all girls. I have some students who know about Legos, and I have some who have never touched Legos in their lives. And so we bring them in and we just kind of play around, and we have these little creations. Another thing I do with Lego is I give them a little, every team will get a stack of Legos. It's all the same stack of 12 Legos. It's a very small stack of Legos. And I say, build something, does anything, just put them in any type of order of structure. They're all touching each other. And once they build it, I then say, okay, now take a piece of paper and I want you to write step-by-step instructions so someone else could build what you've created. And so the team gets together and it takes maybe 10 or 15 minutes to write step-by-step instructions. And then they think, oh, whoops, the size is different. Then I've got to worry about the color, and then where it's placed in the Lego is a little bit different. And then we exchange instructions, and the other team has to build based just on these instructions. And there are some years I'm really impressed and we get them all built and they're beautiful and great. And other years it's typical where the instructions just aren't quality enough for someone else to build. And so we have a little lesson about, when you're coding, you can't expect the computer to read your mind. If you're going to talk about the yellow brick, we have to say we're talking about the yellow brick. And so these are some of the activities I do over the first month. I see my students 2 or 3 times a week of the class. So I would love for you to include in chat maybe some unplugged activities that you have that you could share that I could steal. So there are standard, I would call, unplugged activities, worksheets and assignments. And just to give a little plug on it, CodeHS has great worksheets and great items for us to always use if you ever need to pass out a piece of paper. I'm about to go into the unplugged stage for my AP-CSP students and CSA students, because we're about to do prep for the AP test. And so I need them to practice on paper. And so they will be walking into my class Monday and Tuesday this week. And we're going to be not even turning on the computers. We're going to be just grabbing paper and we're going to be sketching away here. I apologize. I think my internet might be bugging out every once in a while. I'm sorry about that. So moving on to the thing that I've been working on since about October of the year is this MazeBot game. What is MazeBot? MazeBot is a card game it's a standard deck of cards, including the jokers. So it's 54 cards you would need to do this. Just a single deck of cards. And the other thing that you would need is some type of marker or a token. It could just be a coin. It could be any type of thing just sitting around. These are 3D printed circles because I happen to also have the privilege of having 9 3D printers in my room. So I print everything out in the whole world. So, oh, Kathy, I see what you suggested there. Pixel art is fabulous. I love the pixel art idea. That is because you're producing things, the students are producing things that they can then share and they can be posted, and they're so proud of what they've created. Yes, pixel art is a great one to do. Yes. Yes, the graph paper. Yeah, those are great ones to do. So now with MazeBot, so these 54 cards, and so I call it for my students for time to play the game, and they love it. We'll get out this deck of cards, we'll play the game. If I happen to have an admin walking by, we call this an activity. Eye of the beholder, I guess, right there. Who is this game for? I would say this game is prepared for computer science students of all levels. I have a little company here. And there are 2 ways I've built this game. One version of the game, the original version was with AP-CSP students in mind. And for the AP test, what it requires is this loop right here. Let's see if I got my camera here. A repeat until. And so I have a repeat until card in these that I use. Digital Schoolhouse Unplugged resources to introduce computing concepts. I've never used that before. Thank you so much for that idea. I've never used their Unplugged resources before. The other group that I use this game for now is for my beginning students. When I do it for my beginning students, though, instead of using the repeat until, I use the while loop. They both structurally do the same thing, but logically, I find for my students, the while loop is easier to understand than the repeat until. And so for my beginning students, I will use the while loop. And for the CSP students, I will use the repeat until. This game is designed for one person to play if they just want to challenge themselves to beat the bot. 2 people can play against each other. 3 people can play against each other. You could play up to 4 people against each other, but also if you have to 4, it might be fun to also do it in pairs, and then it could be played with 6 people in pairs. 5 may be a little tricky because we're limited to 54 cards. Students may get a little bit frustrated that they can't get all the cards they need to play if you're playing 5 unique hands. Not saying it isn't possible. I've done it, but you do start to run out of cards a little bit. When do I use this game? Internet out, computer not functioning. Maybe we just need to change the pace because it's been a bad day. I could tell you Friday was the day we played it because yesterday was our prom day. and no one was ready to sit and code. So boom, we just pulled out the game, we played, we're still learning, they think they're having fun. And then I'll be using it again for test prep, because there's a whole set of questions based on the little movement of the robot through the maze, and just to get them familiar with that for APCSP, we'll use it for that. I also just use it, it hits kids in ways that they don't necessarily always get to see, with this physical touching of things, the interaction, the social, and just kind of a fun change of pace. So that's what I'm doing. That's why MazeBot. So let me just show you here. I hope I'm not getting into the weeds too much here, so I apologize if I do, but here's how the game works. If I show you, this is my very first set of cards I ever made. On one side of the cards, there are actions. The actions could be a run, like there's an error card, here's a debug card, here's a move forward card, and you can see I've got these are the different action cards that you can have. Syntax error, logic error, and runtime error are cards you play on your opponent to freeze their coding, that they cannot continue to code anything until they've gotten rid of the error in their code. The purple debug card is your defense card that you would play to remove your error. So if someone's played an error card on you, once you get a debug card, you can play that and remove the error so you can continue on your path coding. And then move forward is to have the bot move forward one space. Rotate is to either rotate in place, left or right. And you can see how the two circles are on there. And that's why I would use these markers to say it's going to be a rotate and you're going to indicate left, or a rotate to indicate right. That if card, so they can follow that condition. And in the bottom right, if you print these out, it won't be quite as messed up as on the screen right here, because it prints out a bit larger. But you say this, it's looking for a condition of can move. If can move left, can move right, can move forward, or can move backward. And then also, is can move a true statement or a false statement? And so you'd use two markers for that. And you can make it so that the bot can cover a lot of territory in one condition. And in the bottom left, you'll see I've got these two blue cards, repeat until and while. Those are interchangeable. So a deck would have one of the two of those. A harder level deck, my original decks I made, they have the repeat until, because I made it for my AP students. And then the set I'll show you in a moment I've switched over to the while condition. I did that this spring for my intro to coding classes, just so they could start using these decks faster. They really struggled with the repeat until concept. There's a sort of a double negative going on in there. Please, at any time, if you have any questions, throw them in chat, because I know I'm going fast with a lot of information here. So the next we'll see, and I don't know of any other game that has ever done this, and there's probably a reason why, but I've tried, is that on the face of every card is the action that we were just talking about. But the back of every card also is a piece of playable game. These are the mazes that you could potentially have the people being solving. So I will tell you the 100% reason I did this is just so I could save money when trying to design this game and use less decks of cards. That's 100% why I did it. It could be a separate maze deck. You could have a separate deck of just mazes. They don't need to be on the backs, but it has not affected the gameplay to have them on the back. It doesn't make any difference if you do. But so the action, I have the action cards on one side and the mazes on the other. If you want to have them just a deck of action cards and then separately a deck of maze cards, you could as well. I do want to show you this one. The numbers are obnoxious. They don't have to be quite that obnoxious. You could print it out larger so you can't quite see the numbers quite so much if you felt like printing it out. So, so these right here, these are the mazes. And what you would do is when we would deal out the deck, you would have, this would be the puzzle that all players are trying to solve. So when you deal out the deck, the green is where the robot's facing and starting, and the robot would have to here move forward and then turn left and come across, and you can see where here repeat would be really helpful right here, then turn right and move down. And the first person to have completed that entire sequence and say the magic words submit and continue. And if you've been doing CodeHS very long, you know that once they've completed their code, there's a button, a blue button that they push that says submit and continue, and it triggers the auto grader at that point. And my students love the submit and continue button. So we have in this game, you have to announce submit and continue. So that is what the maze is for. And then just to show you, so we have the front of the card is the action, and the back is our 54 different mazes. And this is the way the game would get set up. So I would take my deck of cards, and I'll just show you here. So one player would take a deck of cards, and they would deal out 5 cards to each player. They would deal out 5 cards to each player. Then they would set the deck down. The remaining deck of cards becomes our draw pile, and take the top one off that draw pile, and that will become the maze that we're all trying to solve. So we have our dealing out, we have our draw pile, we have the one maze that we're trying to all solve, which would have a little green and red arrow on them appropriately. And then as they're playing, if they're discarding, they would discard a card right here. And once a card is discarded, it's not retrievable. No one else can take off the discard pile. It goes in there. If you happen to run out of draw pile, then we would reshuffle the discard and continue through the deck at that point. But the object of the game here then is to, on your turn, you always start with drawing a card, and you would take your deck and look at it and see what cards can I play towards completing this robot path. And you could play 1 card per turn. You could play 1 on your own path to say continue it along, move, or something like that. Or you could play a error card on an opponent to freeze them. And your lines of code don't have to be, your lines of code, your cards, don't have to be played in order. They don't have to go line 1 through line 4, 5, 10, 12, whatever. You can have, the student can think, oh, I've got a card that can do, I can do my condition first, or I can do the last 2 steps of this first, and then go back and add lines of code in prior. And that's perfectly fine to do. That works out really well. So they can kind of play what they have. So they can play an offensive card, error, or they can play a card on themselves. So here's the setup. And then here's what the game might look like midway through the sequence. Right here, I have, this is player 1 right here. And here's player 2 right here. We have our draw.
Your slides aren't shared. Do you want to go ahead and share your?
Am I not sharing right now?
Oh, not right now.
I will try again. I think I'm having a little bit of internet pickle right here. So let me stop sharing my video. See if I can't give me just a second here.
I can also share for you if that would be easier, and you can just tell me when to switch slides.
Yeah, that'd be great. Sorry about that. Thank you. Was I sharing up until that point in time and then it just dropped out?
No, I don't think it was being shared as we went. But everybody in the meeting does have access to the slides. So I think
I'm so sorry.
No, I will share. Which slide would you like me to start on?
Let's see here. I think I would like to start. That's the perfect spot to go. Yeah, right there. So I apologize for that. I was having a little internet hiccup there. So on the left side of the screen, you'll see some cards vertically there, and that would be player 1 or maybe team 1 trying to play their cards. And then on the bottom of the screen, you would see player 2 with their cards being played there. And in the middle, we have our draw pile, our robot maze pile. That's what we're trying to solve in our discard pile. And so the player on the bottom, they currently are stuck. They can't play any further right now because they have an error card played against them. And that error card is making it, until they play a debug, they can't do anything else to their code. And you can see, I call this bottom section, the cards in front of you, your command center. This is where you're leaving commands for your robot. And also notice that person has left spaces. They're trying to solve this puzzle, and they've moved forward. Then they have this repeat until, and then they're going to need a turn card, a rotate card right there. And they just haven't gotten it to play it yet because they're blocked. The person on the left isn't blocked right now, but they're still waiting for more cards so they can play all their cards out. We need to do bug card, and I was going to forget something else I was going to tell you just now. So the object is, at the very end, you always need to have 5 cards in your hand. So we're always drawing up our hand as we're playing and playing our cards down. So maybe you can go to the next slide for me. So these are all links to files, and I believe I said they were PDFs before. I don't think these are PDFs. I believe these are all Google Slides. And these are the links that if you happen to want to make these, they will look just like the cards to your left. Those would be your action faces. And you could look at these cards. And if you, the first deck, the first slide there is just an example of all of them. And if you print out all the other 2 and following, if you print those out, cut them out, you'll be able to make yourself a deck of cards. And you could tape them to a deck like I have, or not. And then the second file there, maze faces, is these are the different mazes I've used. And they have a beginning and an end, and you can cut them out, and you could use them separately or put them on the cards however you wish. One, I would love, if any of you use this, I would love feedback, because where I am in this process of making this game is I'm in the beginning stages. I've had 2 beta sets created, and I've probably played with my students dozens, maybe nearly 100 times. And so as we play, I realize this could be improved, but it doesn't really do good to play it once or twice. You got to play it a bunch of times, just kind of learn. These are some of the mazes I've done right here. If you go back to that, and then I also have our instructions, and this lays out in much more detail than what I have time for today, the instructions. It shows the scoring of the game. So how do you score the game? I make it score so we favor people who use repeats and ifs and conditional statements, and that explains how the error cards work, and hopefully goes through each individual card, and so you can see exactly how the rules of this go. And so that would be the rules. And then here, this is just a layout. I've shown you this picture of what the game layout would look like. Oh, actually, if you pause here just 1 second, I do want to show you. One of the things I have my students do when they play is, if you look at the bottom deck of cards being played there, hand of cards, Melissa, yes, they are available. If you click on these links in the presentation, they will take you straight to the files you need to print out, and you can just start playing them as soon as Monday. Yeah, I really, and please, I would love for you to do it. I'd love to get feedback, good, bad, and otherwise. If you look at the bottom layout of the cards there, you'll see that 3 of the cards in the repeat until loop, they are offset. That is in the instructions. And I tell my students, if you're going to use a conditional card, an if or a repeat until, those should be offset. Kind of think how they do it in Python, where they're indented slightly down so that you know that that group is working as a unit. So that's, I forgot to mention that before. Okay, Lindsay, could you take us back to the next slide there? Okay, so the other thing I have created, and this is available on CodeHS in the sandbox, is I wrote up a little program that creates random mazes. Now, I didn't get so far as having it put in a green or a red start and beginning, but if you run the program, you can just run it over and over. You'll create little mazes, and you can project it on your board and put a little sticker, a magnet on one end, magnet on the other, and you just create random mazes for yourself. I mean, if these could, if you're handing these to people, maybe not so much, but you can just go to the sandbox, run this program, and create an infinite number of mazes for yourself in the class. And that could be a way of having just the action cards for the students, and everyone's got their own deck of action cards, and we all have to try to solve it. You could play with a whole group of people doing it this way. So I love my sandbox. So, and I think if we go, so you'd have to add the beginning and the end and things like that. And feel free to steal that code and make it your own and make it better and to share it back with me. So that's great. So in my closing minutes here, I want to say that I got this. So here is, I just took this picture at the table I'm sitting at right now. This is my deck of cards. And you can see in the center of the screen is the draw pile, and just below the draw pile is the maze pile. And where the 8 of clubs is, that's my discard pile. And then the person in the foreground here, the bottom of the screen, is playing out their code to complete that zone. And you can see the little circles I put on there to show my little plastic circles. And I believe that bottom one may have completed the maze that you see right there. And the top one, the difference is the top person, now, first of all, they have an error, so they can't play anything right now. They've been frozen by their opponents until they get a debug. The other is some students, as you know, when they want to program their Carol or their Java, just want to say move, turn, move, 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 turn, move, move, move. Ooh, Kathy, I don't know the answer to that. I will try to open that up for you, Kathy. I apologize. I'll try to work on that. Other students will be able to use conditionals. And I have set up a scoring system to encourage the use of conditionals. You get way more points if you complete the maze using a repeat until or an if statement than you would if you just get the just force it all, just one line of code after another. Kathy, I thought I did that right, but I do think, Kathy, that it is published to the sandbox. And if you do a search for MazeBot 2.0, it should, I'm sorry, MazeMaker 0.2, sorry, that it should be found, it should come up with something to find, but I'd have to double check into that. So 28 days ago, I found out, I got the, many of us were asked to present something, and 28 days ago, I just checked this morning, I got my go-ahead for this. And Lindsay, if you could take me to, I think, the next to last slide. I have been working as quickly as I can in a website called the Game Crafter to actually take this game and make it so it's an actual real clean deck of cards with clean instructions that you can shuffle and deal as a normal deck, and you don't have to print it out and use it with tape, Scotch tape. As of right now, I think I'm 48 hours away from finishing it. All the cards are done, front and back. The instructions are done. The packaging is done. All that's done. The last step is that they make you order your own copy and then approve that it's correct, and then send back pictures approving of it. And it takes 14 days for it to come in the mail, and today is day 14. So I was really hoping I would magically get it early and be able to show you this crisp, beautiful deck of cards. But hopefully in the next week, I hope if you go to Game Crafter, you can buy this game. I think that the price is going to be like $12.50. I don't make any money off of that. I make no money. That is just the straight price of the game, just to buy the cards printed out and the box and stuff like that. So there's no money in it for me. It's just, I'm trying to get it done clean. The version that's on Game Crafter is the one that uses the while loop and not the repeat until. So hopefully the Postal Service did not get this to me quite in time, but hopefully that'll pop up soon. And then our last slide, I think. So I really thank you guys for showing up today. I am really enthusiastic about this. This is something I have a great time with my students. This is something that's in my head. Sometimes, you know, it's that you wake up at 2 o'clock in the morning and I have a game in my head and I just try to churn it out in the next weeks or months and get it going. And this one is not unlike that. In October, I was prepping for my year and I woke up in the middle of the night going, oh, deck of cards. And I literally have a deck of cards beside my bed and just boom, I just start Sharpie on deck and just start writing. And so my future plans for this, just because I'm not done yet, or try to get this wild deck completed, should be done any day now. Then I'll get a repeat until that's more associated for the APCSP kids. And then I've started brainstorming how to do it with Carol the dog, Carol, Super Carol, and Ultra Carol. I don't know if I'll be able to do that in the near future, just because if you could go back to the action card slide for me, Lindsay, maybe back 5, that one. So this deck, 1, 2, 3, 4, 5, 6, 7, 8, only requires 9 types of cards. And the Carol would end up needing, I'm right now at 15, I think it would require. And that just changes all the numbers and ratios and stats. And so I'm not sure where I am with that. We're working on that hard yesterday, and we'll see where that goes. So thank you guys for coming and sharing my passion with me. And Melissa, I will, so this is baby, I'll talk to you while I'm talking to the CodeHS people. Melissa, I don't know exactly when they will be available. I am hoping that they will be available by the end of April, and they may be available as soon as Monday. What will happen is, as soon as I get my first order deck to me, then I have to look at it and I have to proof it. I have to take pictures of it, and I resubmit those to Game Crafter. As soon as I've done that, then it will be available for anyone to access. It will just be openly published. And I am certain that that would be by the end of April. I think it'll be within the week that will happen. So I'll get that for you. In the meantime, you can use this beta version, and I don't know if there's a way to communicate with those of you who are here. Is my email available for people somewhere? I think if you see me out there, I would just shoot me an email, emagness@vmhs.org, and I would love to create a dialogue with this. And if you start playing the game and my instructions are not clear, I would love that feedback, or if I could clarify something or help with anything, I would love to help in any way. So in our last couple minutes here, if you have any questions for me now, I will take them. So yeah, let me just do that. So that's my email, and any time I would take it, and any other questions you have for me, I'd take them now. So thank you.
Thank you. And one thing I can quickly add is that there were some questions, and I was talking privately to some people about the sandbox. So the question there was, how would you find it later on in your sandbox? Right now, you would only be able to access it from your link, but there is the option to fork that program. So Lindsay, would you mind opening up the program and sharing your screen and just showing how people would be able to do that? Basically, what we mean by fork in this sense would be you'd click fork, it would make a copy of it to your own sandbox. That would not make any changes. So if Erik were to make changes tomorrow, you wouldn't see those in your forked version, but this would make a copy of that to your sandbox that you can now look at, you can play with and have for the future.
Excellent. And I'm really sorry about my screen share not working prior. I think I had a little internet hiccup and it bumped me off. So I apologize for that. And so right now that sandbox link is working. Is that right? Okay, good. So yeah, click and steal away. Please do.
Okay.
Borrow and make better.
There you go. There you go. Yep.
That was great. I'm thinking, why didn't I have MazeBot when I was teaching APCSP? I feel like some of those kids really struggle with the robot questions on the test, and that would be really awesome for those robot questions. So thank you for that, Erik. That was awesome. We do have more sessions coming up in about 15 minutes. So I've put on the screen what you can expect in the next session. In the main room, we have turbocharged CS with instructional coaching. In this room, we have a ransom note from AI and JavaScript. In room 3, we have the effects of CS on low income and minority students. And in room 4, we have fun with K2 elementary CodeHS. So you can go to codehs.com/TC to get all of those links to each of those rooms. And we will see you back in about 15 minutes in whatever session you go to next. Thank you for joining us. And thank you so much, Erik, for sharing this with us.
My pleasure. Thanks, everyone. Good luck at the end of the year there.